All right, so for this one, this has the terminal side of an angle in standard position that passes through the point -5 comma or -9/5 comma 6. So again, we have to sketch the drawing. And it doesn't have to be perfect. Like, don't really worry about it too much. Where is -9/5? It's somewhere over here. So when you have a positive x and a negative x and a positive y, that means it lives in the second quadrant, quadrant 2. So somewhere over here at -9/5 comma 6/5. Now remember, those are x comma y's. So you're going to have a triangle, a perfectly drawn triangle, and we're going to have a reference angle here of theta. Now it doesn't matter, but because x is this value, right? -9/5, right? Because that's how far you go over to get to this x coordinate, right? And then this would be 6/5. So your x value is technically your adjacent value, and that's -9/5. Your y value will always be your opposite value, and that's currently 6/5. And then r is your hypotenuse, which is the radius of the circle. But to find r, we got to use the Pythagorean theorem. So remember that x squared plus y squared is equal to r squared. Well, x is -9/5 squared. Y is 6/5 squared is equal to r squared. And when you square a fraction, you just square the top number and you square the bottom. A negative times a negative is a positive, so this just becomes 81 on the top. And then 5 times 5 on the bottom is just 25. Plus 36/25 equals r squared. So we'll use our calculator. We're going to say 81 plus 36. It'll take us a second. So I'll say 81 plus 36 equals 117. Ooh. That is not good. That equals r squared. So now to get r by itself, I have to take the square root. But remember, I could take the square root of these two separately. In other words, I can have the square root of 117 all over, the square root of 25, which is just 5, equals r. So I'm supposed to think to myself, is there a perfect square that fits in the 17? So one part of that process, I don't think there is. I think 117 is a prime number, but we're going to try it and see. So you take 117, what's 2 squared? 4. Then I take 117 and divide it by 3 squared, which is 9. Oh, lucky me. So that means, that this bad boy right here is the same as the square root of 9 times the square root of 13. I wasn't sure that was going to work. You have to trust the process. So we're almost done. The square root of 9 is 3, so 3 root 13 over 5 is my radius. Now that is not fun, but we're just going to have to do the math. So then remember that sine of theta is equal to y over r. Y is 6/5 all over the radius, which is 3 root 13 over 5. Now remember, technically we're taking 6/5 and dividing it by the fraction 3 root 13 over 5. So whenever you divide by a fraction, you have to multiply by the reciprocal. So I'm dividing by 3 root 13 over 5. So therefore, I multiply by 5 over 3 root 13. The 5s will cancel, and I've got 6 over 3 root 13. That equals 2 over root 13. But I have to rationalize the denominator, which is root 13, all over root 13. So my final answer is 2 root 13 all over 13. That was a lot of work. Cosine of theta is equal to x over r, which is equal to negative 9 over 5 in parentheses all over 3 root 13 over 5 all over in parentheses, which is equal to negative 9 over 5 times the reciprocal, which is 5 over 3 root 13. This cancels with this, and this actually cancels with 3 of these. So in other words, 9 divided by 3 is 3, 3 divided by 3 is 1, 5 divided by 5 is 5, so we get a negative 3 over root 13. But then remember, I have to rationalize the denominator. And that gives me negative 3 root 13 over 13. Okay? Tangent of theta. That's going to equal y over x. So I'm going to get 6 over 5 over x, which is negative 9 over 5. That's the same as 6/5 times 5 over negative 9. The 5's cancel. I get negative 6 over 9, which reduces down to negative 2/3. And then I'll let you guys do the remaining 3, but they're just the reciprocals of those. You just have to make sure that you rationalize the denominators and whatnot. Okay?